In this lesson, we are going to be looking at simplifying radical expressions. So, first of all, we need to remember what the perfect squares are. We're going to be looking for perfect squares. So, perfect squares, the list like 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 16. 5 times 5 is 25. See if you can list these. And we have 36, which is 6 times 6. 49, which is 7 times 7. 64. 81. 100. We keep going. 121. 144. These are all perfect squares because you can take the square root of them and you can have a full number. Okay, so this is what we're going to be looking for today. You're going to be taking some radicals and you're going to be looking for some factor pairs, and one of the factors has to be a perfect square. Has to be one of these numbers on the list. So let's see what we're talking about here. Here we have simplifying the square root of 12. Now this is not taking our calculator and typing in what is the square root of 12 and getting a decimal. We're not using our calculator at all. This is just simplifying it and our answer still being with radicals. So what you do is you think back and you're going to think of factor pairs of 12 and you want to use the largest perfect squares you can. So if I think of factors of 12, I have 1 times 12, I have 2 times 6, and I have 3 times 4. In those, which one has a perfect square? Right here, 4 is a perfect square. I can take the square root of 4. So what I want to do is I want to break this down into 3 times 4, which can also be the same thing as the square root of 3 and the square root of 4. We can break it down into the square root of 3 times the square root of 4. Now, once you do this, we can take the square root of the perfect square. We know that the square root of 4 is 2. So our final answer is going to be 2 times the square root of 3. That is the simplified expression. So you're finding a factor that is a perfect square. You're taking the perfect square, which pulls it out of the radical in front, and that leaves what's behind. That's kind of what we're doing here. We're going to go through some more examples. There it is broken down. Okay, so here we have the square root of 50. Well, when I think of factor pairs for 50, I have 1 and 50, 2 and 25, and I have 5 and 5. Well, only one of those has a perfect square as one of the factors. That's 25. So I can break this down into the square root of 2 times the square root of 25. Because together, 2 times 25 is 50. Now I can take the square root of 25, which is 5. So my simplified answer is simply 5 times the square root of 2. And I'm done. See, no reason for a calculator. We're just going to use our brains today and simplify the best way we know how. Okay, this is starting to get a little more difficult. Now this says 2 times the square root of 18. So basically it's saying 2 times the square root of 18. 18 is not a perfect square, but if we think of factor pairs for 18, 1 and 18, 2 and 9, we know that 9 is a perfect square. So we can break it into these two factors. So we would have 2 times the square root of 2 times the square root of 9. So all I did was break this into two factors. Now, I can take the square root of 9, which is 3. Now, if you look at what's outside the radical sign now, you have a 2 times a 3, and then underneath the radical sign, you still have a 2 because we couldn't take the square root of this. But now we have to actually multiply what's outside the radical together. So our final answer would be 2 times the square root of 6 times the square root of 2, which we also read as 6 root 2. Another way to say it. So here was 9. We took the square root and made it 3, and then we did 2 times 3. Okay, so again, here we have 8 times the square root of 28. 28 is not a perfect square, so I think of factor pairs for 28. I have 1 and 28. I have 2 and 14. Neither one of those is a perfect square. I have 4 and 7. These are the only factor pairs I can think of. Here is one with a perfect square right here with 4. So I have 8 times the square root of 4 times the square root of 7. I can take the square root of 4, which is 2. So now I have 8 times 2 times the square root of 7. And so my final answer would just be 16 root 7, or 16 times the square root of 7. Here it is with the PowerPoint. So we take the square root of that, 16 root 7. Okay, now we're going to add some variables underneath the radical sign. Okay, 16 happens to be a square root. So first thing we're going to do is we're going to break this radical sign into two parts. We're going to, since this is a perfect square, we're just going to leave it as 16. But then we're going to think about what is the square root of n squared. Now, when you have a variable, you want this to be an even number, because even numbers can take the square root of them. Because we know n times n equals n squared. So that means the square root of n squared is equal to n. If we have n to the 4th power, and we take the square root of that, it would be half of it. It would be n squared. So as long as your exponent is an even number, you can take the square root of it, and it's just half of it. So up here we have both of these happen to be perfect squares. I can take the square root of 16, which is 4. I can take the square root of n squared, you half the variable, and it's just going to be 4n, and I'm done. So both of those happen to be perfect squares. So you took the square root of both of them, and you're done. Okay, here we have 20n squared. Well, I know that n squared is a perfect square, so I can keep that here. 20 is not a perfect square, so let's see if I can think of some factor pairs to break it down into. There's 1 and 20, there's 2 and 10, there's 4 and 5. Here we have a perfect square. So I'm going to break this one down into root 4 times root 5, which equals root 20. I can take the square root of 4, which is 2. I can take the square root of n squared, which is n. I cannot take the square root of 5 and it be a whole number, or it would be a decimal. We don't want that, so we're just going to leave it underneath and say that our final answer is 2n root 5. Here it is again. You're just taking the square root of this, taking the square root of this, 2n root 5. Okay, this time we have two variables. So let's break it down. First, we have the square root of 25, which happens to be a perfect square, so that's good. Then we have the square root of x squared, which happens to be a square root as well. And then we have the square root of y. There's an invisible 1 right there, so that's not a perfect square. We cannot take the square root of that. But we can take the square root of these two. The square root of 25 is 5. The square root of x squared is x. And since we can't take the square root of y to the first power because it's not an even numbered exponent, we're just going to leave it underneath. And there is our simplified answer, 5x root y. So there it is again. Take the square root, take the square root, pull them out, 5x root y. Okay, let's look at this one. 90 is not a perfect square. We have x to the 4th. That is a perfect square because the exponent is even. And we have y squared, which is a perfect square because the exponent is even. So I've got my x to the 4th power, and I have my y squared. I can take the square root of both of those. 90. Let's see if we can find a factor pair. I know that 9 times 10 equals 90. And I know that 9 is a perfect square. So I'm going to break this into 9 and 10. Now let's take the square root of all of those that are perfect squares. 9, the square root of 9 is 3. The square root of x to the 4th, you half the exponent. The square root of y squared, half the exponent, so that would be a 1. 10 is not a perfect square, so we're going to leave that underneath the radical sign and say our simplified answer is 3x squared y root 10. There it is again, the PowerPoint. Take the square root of the 9, the x, and the y. I hope this helps you simplifying radicals.